1 was all about solving graphically. Historically, that's the way they used to have to do it, because algebra hasn't been around forever. So they try to find a solution, and they did exactly what happens to us when we're doing those graphically. We're like, but it says it's supposed to be right here where they cross, and we put them in and it doesn't work, because we're a little bit off with our graphing. And somebody came around and said, hey, I learned this new stuff called algebra. Let me show you this. And they learned that with algebra, you can get the perfect answer in just a matter of 6 or 7, 8 steps as you go through. So we're talking about the 2 algebraic methods from yesterday. Substitution, and it's called elimination in this book, linear combination, and a lot of other books that will help us solve algebraically. And we were in the midst of elimination yesterday when I just quite frankly ran out of time, and the video was kind of long anyway. So elimination said either get your x's to be opposites or your y's to be opposites. The nice thing was yesterday the book made it so they already were. We didn't really have to do anything to get the opposites. So now I think, well, what happens if these aren't lined up as opposites? So what do? Because I could use substitution. I could get x or y by itself, but it's going to have a lot of nasty fractions. Nobody likes that. So here's what we do. We multiply one or both equations. Oops. Did an English both with an E at the end. Both equations to make opposites. Multiply one or both equations to make opposites. And you start to think, well, maybe somebody else will pick different opposites than I do. As long as they do it right, it doesn't matter. If you do the math right, it's going to work. So I look at these two, and I think, all right, if I went after the x's, those are 2 and 3. Smallest numbers I could go after would be plus and minus 6. Of the least common multiples. If I decided to go after the y's and make those opposites with a 5 and a 7, ooh, the smallest one I'd be able to do would be 35. Now, we could do it either way. In fact, we could pick bigger numbers than that, but what you want to do is make it the easiest method possible so that you're less likely to make mistakes. So I'm going to take my top equation there, 2x plus 7y equals 4. And I'm going to multiply it by something, so I get a 6 and a negative 6 in the x's. And then I'll do the opposite sign for the bottom one. So they'll have positive 6x and negative 6x. Now myself, I like to get the negative done right away. So if I need this to be a negative 6x, I'm going to have to multiply this entire equation by negative 3. Because we know that that follows the laws of algebra. We can do that. We can multiply an entire equation by something, and it will be equivalent. And then on the bottom, I'm going to multiply that one by 2. Because again, my focus is to get a negative 6x and a positive 6x. Then when I add them together, the x's will be eliminated. That's why it's called elimination method. So first things first, let's multiply that top equation by negative 3. And we get negative 6x minus 21y equals negative 12. And then I multiply my bottom, my red equation. And get 6x plus 10y equals negative 10. And now I stop and make sure that what I did is going to work. Yeah, negative 6x plus 6x. Yay me! Got it. Because I want to add these together. And eliminate the x's. Negative 6x plus 6x is 0. That's exactly what I wanted to happen. Negative 21y plus 10y is negative 11y. And negative 12 minus another 10 is negative 22. I like the way this is going. So now I divide both sides by negative 11. and I get y equals 2. It's always a good feeling when you get an integer. You're like, well, something went right, or I wouldn't get a nice number like that. So now I have y equals 2. But I'm not done, because remember I was trying to find that one point where these two lines are going to hit each other. So I need the x. So now I go back up into either one of these two. Up here, that's not a really good looking bracket. And I try to figure out which one of those two I'd rather work with. And I see a negative in that bottom one. And I remember the most commonly made mistake in mathematics involves negatives. So I'm going to stick with the top one. And I'm going to put my y value of 2 in for y. And just do a little bit of algebra. And I'll be able to figure out what x is. So 7 times 2 is 14. And I subtract 14 from both sides. 2x is negative 10. Divide both sides by 2. And x is negative 5. And last but not least, I was looking for an ordered pair. So I have to show this is the ordered pair, negative 5, 2, star it, box it, circle it, something, so that I'll be able to see, you know that's the solution right there. So that's elimination method. You know, the elimination part comes from, are you going to get rid of the x's or are you going to get rid of the y's? What do you have to multiply to make that happen? So far, so good? All right, so I'm going to ask you more questions on this one. We've got 4a says 3x plus 7y equals 15. And then 5x plus 2y equals negative 4. So the first thing I do is ask myself, is this a good substitution problem? Is there an x or a y that's kind of all by itself? The answer is no. So probably better to do this one by the elimination method we were just using. So help me out here. For the x's, what would be the smallest number we'd be able to use for those?
15.
15. So I'm going to kind of keep that in mind. This would be plus or minus 15 for those x's. How about for the y's? 14. Now, here's an argument both ways. Some people say, oh, I'd go with 15 every time. Multiplying by 5 is super easy. I'd rather do that. And other people say, well, 14 is smaller than 15. Why wouldn't you just multiply by 7 and 2 and get the 14? The good news is, if you do it right, it doesn't matter. Both ways will work. I always stick with the smaller number. So I'm going to go with the 14 here. And I'm going to multiply the top equation by negative 2. So I can get that negative 14y, because remember I need opposites. And then I'm going to multiply the bottom equation by 7. So I'll get that positive 14y. So if you haven't already, go ahead and distribute those numbers. And then we can all look up here and make sure I'm doing it right and you're doing it right. Looking good before you get too far and catch a mistake? Did what we want to happen happen? Yeah, we got a negative 14y and a plus 14y. So those two are going to drop out, eliminate each other. So this would give us 29x equals negative 58, which makes you a little nervous until you do your division. Because what's negative 58 divided by 29?
2.
Negative 2. Then you feel better. So now we have x equals negative 2. Go way up here to the black two equations. Would you be using the top one or the bottom one?
Top.
Doesn't have the negative in it. Again, it doesn't matter. Either one of them, if you do it right, is going to work, but well, it's better to be safe than sorry. Let's see, our x value was -2. Plus 2y equals -4. Again, this is some basic algebra we're going to do here. So -10 plus 2y equals -4. Add 10 to both sides. And divide by 2. Oh, I should move that up so you can see both pieces here. Everybody a match? So how do we finish it up?
2, -3.
-2, +3. I think you just said it backwards. I do that too. It's like they transpose, the numbers transpose in your brain. And you're doing that. -2, 3. Now, yesterday, we spent a lot of time going through and checking our answers. That's why I'm not checking all of our answers today. When you check your answers, you just put this in for x in both spots, this in for y in both spots, and it has to make both of those true. That's how you know it works for both of those equations. So you can always do that. Now, part B says, in problem 4, so that'd be this one up here. Once we had this, I chose to put it in the first equation, the top one. Do you suppose it would matter if we put it into the bottom one? Would we get a different answer? We better not, or we did something wrong. Because remember, it has to work in both equations. So, when it says substitute this value into the other one, did you still get the same x? The answer is going to be yes. And explain why. It has to work in both equations. That's the only way that we know it absolutely works, is if we can check it into both equations and it works in both. So it won't matter which one you plug it back into, you should get the right answer. If you don't, well, you miffed it somewhere. Go back and check your negatives, all that good stuff. All right. Those, I really think, were the two most challenging problems this week. You feeling okay about those? All right. Well, then let's keep going. Learn a little more. Don't have much left. This says goofy stuff's going to happen. Solving systems without unique solutions. What are the solutions of the following systems, and explain? Well, let's see. I look at A, I start thinking right away, ooh, that's a good substitution problem. I'm going to take that top equation and I'm going to solve for y. So what I'll do, I'll add 3x. Y equals 3x minus 5. Okay? And now it's called substitution because we would take this, since it's y, and we would substitute it into the other equation, the one we haven't used yet. So this was the other method that we covered yesterday. And it will say 3x minus 5 equals 5. Again, we've got some basic algebra to do. I've got a negative out in front, so I have to pretend it's a -1 and multiply everything in there by a -1. Wait a second. 3x minus 3x, what's that?
0.
It is 0. So this is going to say 5 equals 5. When does 5 equal 5?
Always.
Always. So how many solutions is it going to have? Infinitely many solutions. Now, I want to tie that to the graph. So I remember from a few days ago when we were talking about 3, 1, that means these were actually exactly the same line. because one line is right on top of the other and they will always intersect. Now, we could have told that if we'd have solved both of these for y, because when we did y equals mx plus b slope-intercept form, we would have had exactly the same equation as we went through there. But algebraically, as soon as we get something that makes total sense and is always true, we write infinitely many. Alrighty, looking at b, looking for the best method. It wouldn't be substitution this time. It'd be hard to get the x or the y by itself without having fractions. Wait a second. There's already opposites up there. I can use elimination, what we were doing today. I'll just add those buggers together. Find my solution. Well, 4x minus 4x is 0. That's good. Negative 6y plus 6y is 0. When does 0 equal 16? So what do you suppose we put for solutions?
No solution.
Exactly. Doesn't have any. Again, thinking graphically, what kind of lines will never have any solutions? Yeah, these were parallel lines. If we did y equals mx plus b, we would see the slopes are exactly the same. So there it is. But we're using algebra to figure that out versus, trying to see what the lines look like. Both work if we do it right. All right, everybody, 5A. What would be the best method for 5A? What do you see? Okay, here's how you know again. Would it be super easy to get an x or a y by itself? You can. However, we don't encourage that because people are usually much better at multiplication than they are at division. But you could. It will work. Because that's a property of algebra that you can divide the same thing from both sides of an equation and it will be equivalent. Yeah. Would it be easy to get an x or a y by itself with this one? Yeah. So I'm going to take that top one and I'm going to get y by itself. All I have to do is add an x to both sides. Now, this is where it gets its name from. I substitute. So wherever I see a y, instead, I put x minus 2. So it will be 2x minus 2 times the quantity x minus 2 equals 0. And again, we just have to be careful about distributing the negative. So 2x minus 2x plus 4 equals 0. Wow, 2x minus 2x, that's 0. So this thing says 4 equals 0. So what do we put? No solutions. And in the homework, if it asks you what type of lines would do this, what could you say?
Parallel.
Parallel lines. Exactly. Parallel lines. Never going to hit each other. Alrighty, I'm looking at B. And I'm thinking to myself, well, substitution again. I can get y by itself super easy and fast. Now help me out. Where do I put that? Where does it go so I can continue the algebra? Fine. I'm just going to walk around and eavesdrop on your papers then, because I can see you're doing that. You just don't want to talk. Make sure everybody uses this. Worry was that people weren't going to watch yesterday's video and then come back and say, I'm lost. Well, that's obviously not the case. Some of you look like you've been done and waiting for me for a while here. Okay, good. All right. So we plug it into the bottom one. And we distribute. And we get 18 equals 18. And we write down infinitely many solutions. Oops, I'm writing too fast for the smartboard. Infinitely many solutions. All right, so obviously you are then ready for a challenge question because this is a piece of cake for you. All right, so did any of you solve that one differently? What did you do instead of substitution?
I divided on the bottom equation by 3 to save the top.
Exactly. So Ella's saying, you know what? I noticed if I divided all of this by 3, that these two were exactly the same thing, which is great. On a test, remember, she'll work. That's the part that it's going to be hard for me to know.
So I decided that
Probably not, and here's why. I think in the instructions it says that you have to do it a certain way. I'm pretty sure it says by using substitution or elimination, blah, blah, blah. So yeah, you'd have to pick one of those two methods to go through. Anybody else do something different than that? So once I said substitution, you said, yay, let's go. Because we could have multiplied this top one by -3, and then everything would have dropped out, and we would have had 0 equals 0. That's another way you can do that one. So, usually by the time we get to the test, people want to know, well, which one should I do? It's you. On the test, there will be one that says you have to do this one by substitution. There'll be another one that says you have to do this one by elimination. But then there's going to be a couple where it's up to you. You know, I would always encourage, if you can get x or y by itself, use substitution, easiest way, fastest way. If you can't, then go after elimination. Well, you guys are obviously totally ready. Learning objective is well behind you. You waved goodbye to it long ago. I know how to solve these algebra. I've got this. So there it is. Now, the very first one is a word problem. But that's okay. You just have to think a little bit more about how to set up. It is also an FAQ. So, and I could, obviously, I've got time to help you to wander on and help you set that one up. I think once you get past the word problem,